Hello and welcome to another one of these ADD videos. We're going to be taking a look at this example here to help understand the concepts of linear kinematics. So when we're looking at this problem, we've got you're tying your shoe and your best friend taps you on your head and you take off running after him and accelerate at a rate of 1 meter per second squared. Your buddy is running at a constant velocity of 3 meters per second. Okay. For simplicity purposes, we're going to assume that he's running in a straight line. And we want to know how long it takes you to catch your buddy, how fast you're running when you catch him, and how far you both ran. So let's take a look at this. So what we need to realize is that the distance for both people will be the same when you catch your friend. Okay, so runner 1, runner 2 will have the same distance. So when we're looking at runner 1, you're tying your shoe. So you have an initial 0 velocity and an acceleration of 1 meter per second squared. Runner 2 has 0 acceleration because of the words constant velocity. V1 equals V2, so there is no change in in velocity for acceleration. And the velocity is 3 meters per second. So what we do is we look at each runner individually. Runner 1 had 0 velocity. We're going to call the starting point 0 for both runners. Okay, that's the point he passes me. And there's your acceleration right there. So simplify, there's runner 1. Now runner 2, 3 meters per second, but because it's a constant velocity, there's 0 acceleration. There's runner 2 formula. Now what we do is we know that they equal each other in distance, so set the two distances equal to each other. Now don't divide anything out, bring it all to one side, factor out the common t, and then you'll be left with this expression here. Take this divided by this to get that, this divided by this to get that, and you're going to end up with this expression here. Solve for t, 3 on both sides, and divided by 0.5. When you do so, you get 6 seconds. So now that you know the time, you can calculate the other parts pretty easily. To calculate how fast you're running when you catch up to him, use this formula. Your initial velocity was 0, accelerate at this rate, and we now know the time. So seconds squared cancels with seconds. You get 6 meters per second. So you're going twice the speed, basically, or twice his velocity. So, and then finally, how far do you have to run? Just plug in the time into either this formula or this formula, and you should get the same thing. 6 seconds, 18 meters. All right. When dealing with these linear kinematics problems, ask yourself what's given, what do we know, and then try to determine which one of these equations of constant acceleration you're going to use. Set the two distances equal to each other. Solve for the time. Use that time to find the velocity and the distance. Thanks for watching. Have a nice day.